Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Thermarrows by Yitrio. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have yin-yang shading, where we need to shade some cells such that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected. And no 2x2 area is fully shaded or fully unshaded. So here's an example of a valid yin-yang shading, because what does it mean to be orthogonally connected as a region? It means you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So for example, to get from here to here, you go along these edges while staying within the region, and you can get to that cell. And you can do this with any two cells in the same region. So for example, to get from this unshaded cell to here, you just go along these unshaded cells. Oops. You go along these unshaded cells all the way to that one. Here's an example of an invalid shading, because now these cells cannot get to these cells here just by going through edges while staying within the region. They either have to go through a corner or go through an edge and exit the unshaded region while getting to the other cell, which is obviously not allowed. This is also an invalid shading for yin-yang, because now this 2x2 area is fully shaded, and no 2x2 area can be fully shaded or fully unshaded. So that's an example of how yin-yang shading works. Circled cells may either be shaded or unshaded, and each line outside of the circled cell must contain at least one shaded cell and at least one unshaded cell. So this is actually not valid here, because you have to have one shaded and one unshaded cell on each arrow. Circled cells combined with shaded cells along the attached line act as a valid thermometer clue with a circle as the bulb. Okay. The digits, in other words, digits must strictly increase along the line from the bulb to the tip on unshaded cell, or sorry, shaded cells. Any unshaded cells other than potentially the circle are ignored for the purposes of the thermometer. So all the circled cells are the bulb of a thermometer, and digits must strictly increase from that bulb to through the shaded cells on the arrow. Unshaded cells are ignored, though, other than the circle. Also, circled cells combined with unshaded cells along the attached line acts as a valid arrow clue with the circle as the bulb. And all unshaded digits along the line must sum to the digit in the circle. Any shaded cells, other than the potentially the circle, are ignored for the purposes of the arrow. So let's try to figure this out. So if we have something like 2 and 3 here, this would must sum to 5, no matter what, because the unshaded cells along the arrow must sum to the digit in the circle. And for the shaded cells and the bulb, no matter whether it's the bulb is shaded or unshaded, it must act like a thermometer. So you have to have 5, you could have 5, 6, and 8 here. So this would be a valid arrow, because you have the digits that are unshaded adding up to the digit in the circle. So the unshaded digits along the arrow add up to the digit in the circle, And then the digits in the unshaded cells are all increasing going from the circle to the tip of the arrow. So that's an example of, again, of how, because 2 and 3 add up to 5, and then 5 is less than 6, which is less than 8. Interesting. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so for circle, so every arrow has at least one unshaded cell and at least one shaded cell. Um, okay. That means for 3 cells, particularly if they're in the same row or column or box as the circle, they cannot be the same digit. Right? Sorry, you cannot have one unshaded cell, because then that one unshaded cell would be the same as a circle, and therefore there are 2 unshaded cells here, and then 1 unshaded cell here. What about for 4? Again, you have... Oh, okay. So, along the edge of the grid, so for yin-yang shading, you can only change shadings 0 times or 2 times. Again, because each of the arrows must have a shaded cell and an unshaded cell, somewhere along here is going to have to be a break. So it's either going to be... So this is going to be a different shading than this. That's all we know. So let's make this red, and same with this. This is red, and this will be orange. So the reason why we know that, again, is that we have a 0... You have either 0 changes of shading or 2 changes of shading. You always have to, out on the edge of the grid, always have an even number of changes of shadings, right? Because if you change from one to the other, you'll have to change back eventually, right? So that's going to be, you always have orders of 2. Now the thing is, you cannot have more than 2 changes of shading on the edge of the grid. And the reason why is, let's try it out. Say we have a change of shading here, a change of shading here, change of shading here, and then a change of shading here. Well, if you orthogonally connect the red regions, the problem is that will necessarily break the orange regions into 2 separate regions when it's supposed to be all one fully connected region. And so therefore, you know that the change of shadings has to be, since you have to have one of each shading at least on each arrow, these must be the same shadings, and these must be the same shadings. Okay. There are no 2x2 areas that are fully shaded or fully unshaded, so this must be red here, that must be red there, this has to be orange here, and this must be orange there. Okay. We have to have at least two. Um, let's see. In the 3 area, we have to have two unshaded cells, but we don't know which one is shaded, which coloring is shaded, and which one's unshaded right now. Oh, this is interesting. On this arrow, we have 6 digits. You can have at most. Now that's interesting. Okay, so for 6 digits, you could have one digit be equal to. So one of these has to be orange, guaranteed. One of them's already red for the arrow, so that's fine. Um, and the thing is, you can only have 3 unshaded cells at most in that possibility, right? For these 6 cells. Because you guaranteed have to have. If you have 4 unshaded cells, they will add up to at least 1, 2, 3, 4, which is 10, which a single digit can't add up to. So that's not going to work. So that means you have 3 unshaded cells at most. But do you have to have more than one, even? I think the answer is no, right? We do know there's a lot of reds that have to be here. We can't have all of these be orange, right? We can't have 5 orange there. We could have 3 orange, though. And specifically would have to be orange here, orange here, orange here, if that's the case. Which would make that red, this red, and you have to orthogonally connect the red cells together. So these would all have to go out that way. So that is potentially possible if we wanted to divide it into 3 and 3. Obviously, you could have less than 3 oranges in that space, but 3 is the most oranges you can have on this arrow. Um, hmm. Um, can we have 2 digits adding up to another digit? Yes, you can. That could be perfectly fine. Or just 1 digit, right? Because the circle and the digits on the arrow are not on the same column, you could have 1 unshaded cell here, right? Uh, uh, okay. For these digits, for each of these sets of arrows, you have to have 2 in each. Sorry, 2 unshaded at least. So for this set of 3, this set of 4, this set of 4, this set of 3. Well, this one You don't, because it's the circle and the arrows are not in the same row, column, or box. Let's look at this area here. One of these is orange. If we have an orange here, let's say the oranges are the unshaded cells. So if oranges are the unshaded cells, we have to have two oranges here. So therefore, these must be orange. So orange, assuming orange is the unshaded cells, we have a 2x2 area that has three oranges in it. So that must be red, which means it changes there. So then this arrow only has one orange in it, which would be unshaded, which would mean this digit would have to be the same as that digit, because this is the sum of all the unshaded cells on the arrow. But then they would have a repeat in the row, which is not allowed. So orange cannot be the unshaded cells. Orange has to be the shaded cells. And then red must be the unshaded cells. So these are unshaded here. The blues are shaded. We have to have at least in every row or column where the circle and the arrows are all in the same row or column, you have to have two unshaded cells at least on the arrow. So these both must be green. So this has to be greater than this cell here. We have to have two greens on each arrow that is in the same row or column. So we guaranteed one of these is green, which means the other one has to be blue, because otherwise we'd have a 2x2 area that's all green if it were not green. But we need two greens on this arrow. We need two greens on this arrow, and it cannot be these two, it cannot be these two. So it must be green here and green here, which makes that a blue. Blue has to orthogonally connect out, so this is blue and blue here. We have the same problem here. This has to have two greens on this arrow, otherwise we have a single green adding up to the same digit, which is on the circle, which is in the same row. So this must be green and green. Blue again must orthogonally connect, so these have to go out this way. One of these is green, the other one is blue. So this is a green-blue pair also. We can have at most three greens. Okay, we can't have that many blues on this arrow, right? Because then that would all form a 2x2 area. So we have to have three blues on this arrow, which means they have to be here, here, and here. That leaves these as green, which sum up to the digit here. And this digit must be smaller than three other digits, so this must then be 6, which is the smallest digit that three unique digits can add up to, 1, 2, and 3, and then 7, 8, and 9. So this becomes 6, we have 7, that's 8, this is 9, and we have a 1, 2, 3 triplet on the arrow. And the greens have to orthogonally connect out, so this must be green here, this can't be green, it must be, sorry, can't be blue, it must be green because the green has to orthogonally connect out, so this can't be green here, it's blue. These are both blue, so one thing we know about digits on a diagonal, so this is what is it? I keep not thinking of the word, but this is a deduction that you can make for yin-yang shading. If you have two digits that are the same shading across a diagonal, one of the other diagonal cannot be the same shade. no matter what, right? So the reason why is if they are the same shade as this diagonal, obviously you have two pinks there, you'd have a 2 by 2 area that's all pink. But what happens if you have a different shading, if you have orange and orange? Well, how do you orthogonally connect the orange cells without breaking apart the pink cells? Or vice versa? And the answer is you can't, right? Any sort of pattern that you try to orthogonally connect the orange cells with each other or the pink cells with each other will necessarily break apart the other region into two separate regions, which is not allowed. So because these are both blue and this is green, this cannot be green here, which makes that a blue. So these are both blue that way. This is green and green. Remaining digits of column 8 have to be 4, 5, and 6, but this can't be 6 because of 6 in the box. So 6 has to be there, and this must be a 4, 5 pair here. Okay. So this is blue. Green has to orthogonally connect out, so this is green there. This must be green to orthogonally connect out, as must this. Okay. We have to have green and blue along this arrow. Same with this. We have to have one of each at least. This can add up to 5 potentially. So we could have 1, 4 adding up to 5. 2, 4 adds up to 6. 2, 5 adds up to 7, so that's not allowed. 1, 5 doesn't add up to 6 because we have 6 in the box. Oh, this cannot be 5 because of the 4, 5 pair in the box. So that doesn't work. 3 and 4 adds up to 7, which is not allowed because of 7 in the box. But 3 and 5 would add up to 8. And then we don't have 4 and 5 available here because of the 4, 5 pair in the box. So this must then be 3 and 5 adding up to 8, which means this digit must be greater than 8, so it's 9. 5 eliminates 5 here, so that's 4. Okay, this digit is greater than 2 other digits, so it cannot be 1 or 2, which means this has to be a 9. That leaves this as a 1, 2 pair remaining in box 3. This is less than 9. This cannot add up to 3, cannot add up to 4. It could add up to 5 here, though. So this must be greater than 5 at least, 5 and 6. If it's 5, it has to be 2 and 3 here specifically. To add up to 6 could be 1 and 5. It could be 7 here, and then that would force us to be 7 or 8. So this could be 6, 7, or 8. If this is 7, this is 8. It could be 2, 5, or 1, 6 here. We don't know. So those are the possibilities. Remaining digits of row 1. Actually, let's do remaining digits of row 2. We have 1, 2, 4, 6, 7 available. Okay. Obviously, this... Well... This could be a 1 here in the circle, because you could have 1 digit here that's only blue, or only green, right? The rest could be all blue. This digit has to be greater than 1 blue and then the circle. So this cannot be 1 or 2. It's 4, 6, or 7. But the circle has to be the sum of 2 unique digits, which would be at least 3. So 3, 4, and 5 could be there. So this digit has to be 2 smaller than this, so it's 5 at most. And it could be 4 or 3 here. Interesting. So this digit must add up to at most 5. So this is 1, 2, or 3. Well, interesting. One of these 2 digits must be 1, 2, or 3. This is a 1, 2, or 3, and this is 1 or 2. which means the rest of the row cannot contain 1, 2, or 3. So the other digit here cannot be 1, 2, or 3. It has to be 5 or 6. And 3 plus 5 adds up to greater than 7. So 3 cannot be here, which means one of these is 1 or 2. This is 1 or 2, and this can't be 1 or 2 because we have all the 1, 2's accounted for in row 1. So this is 3, which means this can't be 3 here. This is either 1 and adding up to 4, or 2 with adding up to 5 here. So this is 1, 5, 1, 6, or 2, 5 here, adding up to 6 or 7. We have a 6, 7 pair in box 1, which eliminates 6, 7 in the rest of the box. So this can't be 6, 7. This can't be 6, 7. So we have to have a 6 or 7 here also. Interesting. And this digit must be greater than the 6 or 7 there, so it can't be 6, 7, or 8. So 1 and 3 or 2, so the digits here add up to 4, 5. So it's either 1 and 3 adding up to 4 or 2 and 3 adding up to 5. This digit can't be 6 or 7. So it could be blue here if this is 5. So then that would be 5, 6, 4, and this would be 1. Or, so the only way this can be blue is this cannot be 6 or 7. It has to be 5 because it must be less than this. And then greater than that. Then this would be 4, and this would be 1. So the only way this is blue is if this is green. And this would be then 5, and we'd have 4 here, and 3 and 1 add up to 4. And then this could be 6 or 7. That would work. Or if this is green, this is 1 or 2, and this would have to be blue and less than that. Wait, could we? No, we can't have 2 greens because that would form a 2 by 2 area that's all green. So this could be 5 or 6. And then you could have 2 there. So 2, 3, and 2. 3 and 2 add up to 5, which would then have 6 there and 7 there. So that's possible. What are this cannot be 6 or 7 because of the 6, 7 pair in the box. So what can be the remaining digits? Cannot be 1 or 2 because one of these is 1 or 2 and this is 1 or 2. No 3 or 4. It could be 5. No 6, 7. It could be 8. So those are the possibilities. So 6 is somewhere in one of these 3 cells. So, So we either have these add up to 6 or 6b here. So I think that means if it adds up to 6, it has to be 1 and 5. 6 can't be here, here, or here because this digit must be greater than that one. So if this is 6, this must be 1, 5. If this is not 6, it's 7. But 6 has to be here, which means this one's 6. So we're guaranteed 1 has to be there. That eliminates 1 in the rest of the row. And the box, this can't be 1, it's 2, which makes that a 1. That eliminates 1 from being here. Now that's interesting. That means if this is green, it must be 3 and 2, adding up to 5 there. which would force this to be 6. So if this is green, if this is blue, it has to be 5 because of the 6, 7 pair in the box. So then this would be 5, that would be 4. So let's do the order. If this is blue, this is 5. That means this must be smaller than 5, so it would be 4, and this would be 1 and 3 adding up to 4. If this is not blue, it has to be green, and it can only be 2. So therefore, this would be 5. This would be blue and 6. And then this would be 7 there. So those are the possibilities. We have a guaranteed 1 there. 1 out of 2 or 4 is here. The other one is 6 or 7. Hmm. This is greater than that, which is greater than that. So this has to be 8 at most, 7 at most. This is 6 at most. 2 digits can add up to 3. So this is 3, 4, 5. This must be greater than that, 4 through 7. This must be greater than that. It's 5 through 8. Okay, so let's go through the scenarios. If this is blue, this is 5. And this is 1, 4, and this could be 6 or 7. So in that case, that's a 5. If this is not blue, it's green, which means it's 2. 2 and 3 add up to 5. So this would be 5 in that case. So we're guaranteed in column 2, one of these is a 5. We'd have to have 2, 5, 6 there, and 7. But we don't know. We don't have to have necessarily that case for if this is blue. But either way, 5 is guaranteed here, which means this cannot be 5 in the rest of the column. This is greater than that, which is greater than that. So it could be 9, 8, and 7. It's a sum of 2 digits. It cannot be 3, because if it's 3, the greens would have to be 1 and 2 as a pair, and that would eliminate all possibilities for that sum. So this could be 4 at minimum, which means this is 5 at minimum, but cannot be 5, so it's 6, 7, 8. We have the same problem, 7, 8, and 9. So we have a 6, 7, 8 triplet now in column 2, which eliminates 6, 7, 8 in the rest of the column. So there's no 6 here. And the reason is because this cannot be, this has to be 4 at least. So that means we have to have at least 5 there to be greater than it, but we can't have 5 there because of 5 there. So this must be 6, 7, or 8, and this is 6, 7, or 8. So this can't be 6 anymore. It must be 1, which means that's not a blue because that's not less than 4 or 5. That must be green, which forces this not to be green, so it's blue there. This must be blue here because of the 2x2 area. That's all green there. And this must be greater than that, so it cannot be 6 or 7, so it's 5. That makes this 4, sum of 3 and 1. 5 eliminates 5 here, so that's 8. That eliminates 8 in the rest of the row, so it's 7, which eliminates 7 here, so it's 6, which is the sum of 1 and 5. 6 eliminates 6 in the rest of the box, so this is 7. 7 eliminates 7 in the rest of the column, so this becomes a 6, 8 pair here. That leaves the remaining digits in column 2 as 2 and 9. Okay. So this is 6, 8 as a pair. One of these is a 9. So 7 eliminates 7 in the rest of the row. So one of these is a 6. None of these digits on this arrow can ever be 1. We have a 1, 5 pair here that eliminates 1 in that box. We have a 1 in row 4, which eliminates 1 in the rest of this row. So this can never be a sum adding up to 1. It could be a singleton 2. It looks like this is the 4 blues and then 1 green cell here. Which means where is 1 in row 2? It has to be here. So that's 1. The rest of the box has to be 2, 4, or 9. Rest of row 3 contains a 2, 4 with 3 or 8. Okay. You could have 4 here be the sum of 2 and 2. That is potentially possible there also. This 6, 8 pair eliminates 6 and 8 in the rest of the box. The sum up to 7 at most, we have to have 6 at most for these cells. So no 6 here because of 6 in the column. Could be here, though. To add up to... So this is greater than this digit here. And it cannot be 9 because of 9 in the box. So this is 8 at most, which means this is 7 at most here. It could be 2 digits, so you could have 3. So it could be 3, 4, 5, 7. This has to be greater than that, at least. So it's 4, 5, 7, 8. Cannot be 6 because of 6 in the box. Okay. Can you have 3 digits? Yeah, you could have 1, 2, 4 here, adding up to 7. And then that would be 8. That does seem to work. One of these digits here in column 3 is a 1, because there's no other place for it in column 3. Hmm. So these could all be blue here, right? That is possible. Where is 9 in row 8? Cannot be here because of the way that the Thermarrows work. Can't be here because of 9 in the box, so 9 has to be one of these two, which means 9 has to be one of those two there. So either this is 9 or this is 9. And this cannot be 9 because of 9 in the column, which means this has to be 9 there. Okay. Where is 9 in column 5? Cannot be here because of 9s in the boxes. Cannot be on the bulb because you have to have 1 digit greater than it. So it has to be either here or here in column 5. Obviously, if it's here, this has to be blue, and this would then have to be green. Remaining digits. Let's do remaining digits on each arrow if we can. This adds up to 6 at most, so this is 1 through 5. 1 through 5 here. This digit cannot be 8 or 9. It could be technically 1, 2, 3, 5, 6, 7. Except 1 can never be on this arrow. So it cannot, it has to sum up to at least 2 for a single digit, right? else do we have? That could be a singleton digit here. These have to add up to at most 7. So these are 1 through 5, because it can't be 6 because of 6 in the row. This can't be 4. If this is 4, this would have to be 3, but then all of these would have to be green, which is not obviously not going to work. So 4 doesn't work. 5 is the same problem. If this is 5, well, I guess you could have 4 there, and then this is 3, which would be the sum of 1 and 2. So that could actually work there. Let's do remaining digits of column 9. We have 3, 4, 5, 6, 7, 9. Obviously, no 6 or 9 here because of 6 or 9 in the box. We have 4 here because of 4 in the row. Remaining digits of column 7. We have 1, 2, 4, 5, 7, 8. No 8 here because of 8 in the box. No 1 here because of 1 in the row. Same with that 4. And... Oh, where's 7 in box 8? Cannot be here because of 7 in the column. Can't be here because they add up to at most 7. So 7 has to be here. And since this is 7, this has to be greater than that. So this must be 8, which makes that a 6. Okay, that eliminates 8 in the rest of the row. And 7 in the rest of the row. So this has to be 1 through 6 here. No 1 because of 1 in the column. 6 eliminates 6 in the rest of this row. 8. Where is 8 in box 8? Can't be here because this must be smaller than 7 and 8. These must add up to at most 7, so must these. So 8 has to be one of these two. But if 8's here, it has to be blue, and this digit must be greater than it, which is impossible because this can't be 9. So this can't be 8, which means 8 has to be here. It cannot be a green because then you have to have a blue somewhere along here, which has to be greater than it. So this must be blue. So this is blue here. This is a diagonal that's blue, which means this diagonal cannot be the same shading. So we have to have blue here because that's green. Green has to orthogonally connect. So this is smaller than this. Therefore, this can't be 7. It's 3 or 4 or 5. This is less than this cell here. Where is 6 in this box 8? Cannot be here because of 6 in the row. Can't be here because of 6 in the row, and this must add up to at most 6. So therefore, we need a 6 there. So these two digits add up to 6. So it has to be 1, 5, or 2, 4. This must be 1 through 5, and it must be greater than this. So this is at least 4 or 5. And therefore, this can't be 5. So these two digits add up to that. So we have to have a 1 here. So we have a guaranteed 1 here. And we have to have it with either 2 or 3. And we know either this is 1, 2, that becomes 3. If this is 1, 3, obviously we have a 3 here. So we have a guaranteed 1 here. We have a guaranteed 3 here. This 1 eliminates 1 in the rest of the box. So this can't be 5 then, adding up to 6 here. 8 means this can't be 8 here. 3 here on one of these cells eliminates 3 in the rest of the row, so no 3 there. Okay. 6 eliminates 6 here. Remaining digits here cannot be 1, 6, or 8, or 3. So we have 2, 4, 5, 7, 9. There's possibilities there. 7 eliminates 7 in the rest of this column. So 7 has to be one of these 3 cells here in column 5. We are guaranteed a 1 here in box 8. We are guaranteed a 1 in the columns 4 and 5, also in box 2. That means 8 eliminates 8 here. Where is the 1 in column 6? It must be one of these 3 cells. It cannot be here. So we have a guaranteed 1 here. Which must be green because that's not smaller than another digit. So we have 1 plus 1 at minimum there. So this is 2 at minimum. And this can be 2 through 7. Remaining digits of column 6 are 1 through 5. No 1 here because of 1 in the column. 1 in the row. No 4 here because of 4 in the row. Remaining digit here. I think it could be everything, right? 2 through 9. One is one of these 3. One is one of those 3. This is smaller than 6, so it cannot be 7 there. It's 4, 5, which means these can't be 5 here. Where is 7 in row 8? Cannot be here because of the way that the arrow adds up. Can't be here because of 7 in the box, so it must be one of these 2, which eliminates 7 in the rest of the box. We have a 4, 5 pair in row 9, which eliminates 4 and 5 in the rest of the row, so no 5 here, it's 8. No 4 here, it's 3, which is a sum of 1 and 2 added up together. 1 and 2 eliminate 1 and 2 in the rest of the row, so no 2 there. It's 9, which means this can't be 9, it's 2. That leaves just a 7 remaining in row 9. 3 eliminates 3 in the rest of this box. 1 and 2 eliminate 1 and 2 in the rest of this box. So we have a 4, 5 pair in box 8, which eliminates 4 and 5 in the rest of the box. So no 4 or 5 here, it's 3. And to add up to 6, this must be 1 or 2. 3 and 1 add up to 4, and 3 and 2 add up to 5, so this cannot be 4. We have a 1, 2 pair in column 3 or box 7 that eliminates 1 and 2 in the rest of the box and column. So this 1, 2 eliminates 1 and 2 there. It's 4. This can't be 2 or 4. It's 9, which cannot be a green cell. It must be a blue cell. 9 and 4 eliminate 9 and 4 here, so that's 2. That eliminates 2 in the rest of this row. 4 eliminates 4 in the rest of this row. So this is 2 and 6. We have 9 here. Remaining digits of column 1 are 3, 6, and 9. Remaining digits of column 3 are 5, 7, and 8. No 8 here because of 8 in the row. Oh, that's interesting. This digit is not going to be equal to the sum of these 2 digits. So it has to be one of them. And it cannot be the same as that digit, so it must be the same as that one. So then this is a green. Blue, we have 3 blues here in the 2x2 box, so this must be green. We have 3 greens here, so this must be blue. And that must be greater than the 4, so this is 6, which makes that 2, which is not greater than the 6 before it. So this must be green. We have a diagonal that's all blue, and it also this cell has to orthogonally connect out, so this must be blue there. This digit is going to be smaller than the 6 here, so this cannot be blue, it's green. We have a 2 by 2 area that's all green, so this can't be green, it's blue. Yeah, cannot be green, so it's blue. And this must add up to 4 at minimum, which means this has to be 2. So this is 2 here. 2 and 2 here, that means this can't be 2, it's 3. No 3 here, no 3 here. 2 eliminates 2 there, and 2 in the rest of this column. So the rest of these cannot be green because we already have 2 and 2 adding up to 4. So these must be blue. Therefore, this is greater than 6. It can only be 8. This is greater than 8, so it must be 9. That eliminates 9 from here. 2 eliminates 2 here, so this is 1, which makes that 2. That eliminates 2 here, and it has to be the same as that digit. So this has to be 5. And that's 5. And this is 7. 5 and 7 eliminate 5 and 7 here, so that's 8. 3 and 9 eliminate 3 and 9 here, so it's 6. Excuse me, no 6 here. 8 eliminates 8 there. We have a 2 by 2 area that's all blue, so this can't be blue. This is green. No 3, 5, 6, or 9 here. No 5 here. It's 4, 7 as a pair. That eliminates 4, 7 in the rest of the row and box. So no 7, no 4, 7 here. That leaves this as an 8. 5 eliminates 5 here, so it's 1 and 5. No more 5 here because of 5 in the box. We have a 1, 3, 4 triplet in column. Excuse me. I don't know why. I've got something stuck in my throat. Anyways, 1, 3, 4 eliminate 1, 3, and 4 in the rest of column 6, so this can't be 4. It's 5, which makes this 4. 5 eliminates 5 here, so that's 4, which means to add up to 6, it must be 2 and 4. 2, that makes this not 2, it's 1. 3 and 1 add up to 4, which makes that a 5 there. This can't be 2, 4, 5, so it's 1. This can't be 4, 5, so that's 3. 1 eliminates 1 here, so that's 2, which eliminates 2 here, so that's 1. And this can't be 1 anymore, it's 2 and 5. This can't be 1, 2, 4, or... this is a 2. 2 eliminates 2 here, so that's 5, which makes that 2. That means this can't be 1, 2, 5, or 4, so that's 7, which leaves this as a 5 here. No 5 here, no 3 here, it's a 6, 9 as a pair. 1 eliminates 1 here. So where's the 1 in column 6? It must be here, and it must be green. We have a 2 by 2 area that's all green, so this can't be green, that's blue. We have to... well, we don't know which one of these is green. This can't be 2, though. So we can't have 1 and 1 be the only greens on this area. So we need another green here. So this must be 1, 1, and 3, adding up to 5, but that can't be 5. Or 1, 1, and 4, adding up to 6, which it can be. So that's 6 there. That leaves this as a 7 there. 7... We have remaining digits in box 5 as a 3, 4 pair. That eliminates 3, 4 in the rest of the row, so this can't be 3, it's 9. This has to be blue, because it cannot add up with the green to add up to that. We have a 2 by 2 area that's all blue, so this can't be blue, it's green. Blue has to orthogonally connect, so it connects that way. Diagonal, that's blue here. These can't be the same color then, so this must be blue here. 2 by 2 area that's all blue here, so this can't be blue, which makes that green. 2 by 2 area that's all green, so this can't be green, that must be blue. And 1 and 1 with 4 adds up to 6. So that's 4, this is 3, which makes this not 3, that's 4 and 3. 9 eliminates 9 here, so it's 3. 7 eliminates 7 here, so it's 4 and 7. 6 eliminates 6 here, so it's 9 and 6. And that's done. This wasn't that bad. I felt like it was more challenging level. Um, yeah, I mean, it just felt like it was kind of straight. If you know yin-yang shading, it's pretty straightforward, I feel. Well, not completely. Yeah, I guess hard is fine. Again, if you have a question about rating, I usually think it's better to overrate the difficulty than underrate it. So, yeah, I'm fine with placing this as hard. But it didn't feel that hard. It felt like it was pretty clear sort of throughout what was going how to sort of approach this, I guess. I don't know. I guess I'll just rate it hard too. Um, Felt a little easier though than that rating. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.